I think she's the last presenter. So the effect of angle ply and tensile strength of unidirectional glass epoxy and Arenga Pinnata epoxy hybrid composite. Please welcome.
Thank you, Prof. Sapuan and Prof.
Yep.
Price and Dr. Nidani. Nice to meet you in this occasion. Take care and stay safe. I'm leaving the hall. Thank you.
Okay, thank you.
Thank you.
Okay, Jamaliah can start.
Okay. Assalamualaikum. We meet again. Okay. So now I will present. Sorry. Okay, I will present the effect of angle ply on tensile strength of unidirectional glass epoxy and Arenga Pinnata. But now I'm doing the hybrid composite laminates. Okay, before this I'm just using the glass and also the Arenga Pinnata, but now I'm hybrid it together to see the maximum stress. Sorry, so this is my presentation outline. For the hybrids, okay. As we can see before, as you can see that the Dr. Chandra has presented before this. Okay, when we do the hybrid, so we can tailor the properties of the lowest material. For this case, what I do is I wanted to tailor the properties of Arenga Pinnata, which is the natural fiber, with the glass synthetic fiber. So that's why I do the hybridization. So when doing the hybrid, we need to consider the different layer layups, the sequence, and also the matrix and the filler that we use in the materials, and also the arrangement of the fiber. Okay, so for example here we can see the direction and fibers taking layup here. Okay, so for example we have what we call is a unidirectional layup. The layup is all in 0 degree, and this is the cross pi, which is the 90 degree and 0 degree. Okay, so and then the quasi isotropic layup, we have negative 45, 0, 90, and 45 and negative 45. Okay, and then we have the helicoidal 10 degree and then 20 and also 30 degree. So we have a lot of different layup, but which one we are prefer to do? Okay, which properties or characteristic we want to study. Okay, so but for my objective is to predict the maximum stress and displacement of the fiber, and uniaxial tension of theta, negative theta to S, which is the symmetric layup, symmetric sequence, but for the anti-symmetric layup staking. Okay, for the hybrid with the glass and Arenga Pinnata. Okay, so this is the stage for the numerical stage for the ANSYS that I have presented before this, which is the numerical validation that was done, and comparing with the other researchers. I think as Sony, okay, and then the convergent analysis to study about the meshing, what is the suitable meshing size that we need to use. So for this study, we used to 8 times X. Rather than using 256 times by 256, because when the meshing size is a lot of meshing size, it will take a longer time to run the software. So so after the test, we take X times X meshing. Okay, so for the modeling, we use X by X times X meshing and X nuded shell to X1. And for the thickness, for the glass is 0.25 millimeter, and for the Arenga Pinnata 0.425 millimeter. So this value is taken from the actual experiment size. Okay, so this is the test specimen. I have briefing before this. For you, the Uniaxial tensile test specimen. Okay, this is the material properties that we use. Okay, the data that we use for this ANSYS. Okay, so this is the example what we did in ANSYS. We can see as the thickness here is this thickness is 0.0025 is for the glass fiber, and we need to consider that ANSYS doesn't have the value of units. So what we consider is we just use meter in ANSYS. Okay, so we make it uniform for the units. So for the stack up is we use, this is for example 45 degree orientation, 45, negative 45, 45, negative 45, and then we symmetric it. That's why we have here negative 45. Okay, so this blue color is for the glass, and this purple color is for the Arenga Pinnata. So this is the hybrid stack up that I use for these studies. Okay, so for the result we get, okay, from the previous result we get glass fiber and Arenga Pinnata, and then when we do the hybrid, so we get the value is in between the Arenga Pinnata and the glass fiber when we do the hybrid. This is because we use the 4 layer of Arenga Pinnata and 4 layer of glass fiber. So it's supposed to be in the between of this material. Okay, so this is the displacement value. As we can see for the Arenga Pinnata, and the value of displacement is not changed very much compared to the synthetic fiber. Okay, so this is the ANSYS result for the tension, for the tensile test. After we put a load here, we can get the maximum deflection. So we call it a contour. We can see the contour before and after the test. So the contour is not very much changed, but we can see from the value is changed. Okay, so for the conclusion, we can get the value of hybrid is located between the glass fiber and Arenga Pinnata fiber. So from the theory also, when we combine it together, we can support each other because we want to improve the properties of the natural fiber. That's why we put the synthetic fiber. So in this case, we use the glass fiber. Okay, so this is some of the different that I use in this study. So thank you.